So the problem states that we have two springs, BA and BC, and you have the stiffness which is the same, meaning if the stiffness is the same and the distances are symmetric, the elongation should be the same also, right? And we have on a stretch length of 3 meters, and the problem is asking for the horizontal force that has to be attached, and we have this value here which is 1.5 meters. So look what happened here. This distance is 3 meters because everything is symmetric. This distance is 1.5 meters. That means that whatever we are seeing here is the stretch length of the spring. And you can calculate that really easy because it's going to be the square root of 3 squared plus 1.5 squared. So stretch length would be 3 squared plus 1.5 squared, square root of that. The stretch or the form length will be 3.354 meters. And we know that on a stretch is 3 meters. When we subtract that, we can calculate the stretching, which is X or S in the formulas that you know from the Hooke's law, will be 0.354 meters. And as you remember, force is equal to K times X or times S, and K is 500 Newton per meter, multiplied by the stretching 0.354 meters. Meters cancel out, and the force in each one of the springs will be 500 times 0.354, 177 Newton. There you go. That's the force that we have in each one of the springs, here and here. Now, by doing a very simple summation of forces in x equals 0, we could calculate that force F, because then we have negative F plus, I shouldn't call this F, I'm going to call F for the spring, plus this plus that, but they are the same. And the angle here, alpha, is very easy to calculate because alpha will be the inverse tangent of 6 divided by 3. That will give you an alpha equals 2 times inverse tangent. 6 divided by 3 is 2. So the angle will be 63.435 degrees. That means that the component of the horizontal component of each one of the springs will be the same. So I'm going to put here 2 times. Why 2 times? Because I'm lazy. I don't want to put this plus this, and I know they are the same. 2 times. This is going to be the force that we just calculated, 177 times cosine the angle that we just got there, 63.435 degrees, equals 0. And then I can solve for the force, and the force will be 2 times 177 times cosine of the angle that we calculated before, and that will be a force of 158.31 Newton. Tell me that this is not easy. I dare you to say this is not an easy problem. Super easy. And a lot of students see the springs once again and they go, how do they do? What do they say? Oh, springs, I'm scared. Look how tough that problem is. Keep watching, guys. See you in the next video. Have a good day.